Alright guys, what I need you to go through and do and look at here is what's important information in this problem. So that's something that's important. What else is important?
The half-life of 5,715 years.
Okay, anything else important? So we have these three amounts of time that are important to keep track of, right?
Yes.
Alright, let's put some symbols on here to help us identify different things. The 6.8 grams.
That'd be the quantity, right?
Which quantity?
The second one.
So if I'm writing this, I might put a little notation here to say that Q0 equals 6.8 grams. Okay, you underline the 5,715 years. What symbol does that mean?
The H.
So let's put an equals H right here. Yes, sir?
One thing we might want to do to the problem to make it easier is just divide the initial quantity by the 1/2, you know,
Now,
T.
please tell me.
Put it over by the Q. This is trying to find. Wait a minute. No, because that's initial. Darn it. Never mind.
Alright.
I really want to go like mine just to get into that.
I think I'm going to set this equal to T here. I think I'm going to set this equal to T here. I think I'm going to set this equal to T. Each one of those parts, T is given to me as those different numbers.
Makes sense.
Make sense, everybody?
Yes.
So now we should be able to write our formula out, putting in some numbers. The quantity that we're looking for is equal to the initial quantity of 6.8 times 1/2. Time is going to be left alone for just a minute. Over 5,715.
Put in your table.
So if you want to use your graphing calculators, you can go y equals all of this, turn that into an x, then set your table to be at 1,000, 10,000, and 20,000, and you're going to get your three answers pretty quickly. Yes, sir?
When I was looking with my graphing calculator, I hit x equals, and it gave me a number like 14.0.
That's because it's stored in the memory for that x value.
Can I change that?
Yeah, you can store something else in there.
What's the point of subscript 0?
Can I store
It's called my original quantity.
Or is that
You can't do x, but you can make up a different number if you needed to.
okay.
It doesn't solve it for you.
All right.
Why wouldn't we go ahead and put time in?
For part A, quantity is equal to 6.8 1/2 to the 1,000 over 5,715, and then you get a value for them. Right? Have we got some values yet?
Yes.
Yeah.
6.023 grams.
And the second one is 2.02.
2.02.
2.
And the final one is 0.601.
Let's write that. You were kidding, is that the hand you used?
How
Is that right?
They really couldn't use the 0.02 at all.
Are you starting to see here why that you get out here a ways, there's not much left,
Yeah.
and so it becomes much harder to be able to discern statistically. Obviously, if you put 40,000 in here, you're still going to have a number, but it's going to be a whole lot smaller, which is why there's a limit to what carbon-14 can do as a dating process. It has a value we get out there too far and it can't work. The second question I have for you, everybody, is do these answers make reasonable sense based on what's happening in the problem?
Yes. Yes.
We agree.
What the C says 0.02.
I got
No,
0.6.
I got
I
0.6.
disagree.
And then I also got that when I put
Okay.
it right.
So point 6.
601.
0.1.
I didn't hear the 6 over there. Okay, that makes a little more sense to me anyway. I thought that was a big jump.
I was confused.
Sorry about that. Now we got that fixed?
I have a question.
Yes.
Okay. I thought like half-life is when it's like halfway gone. So I thought that would mean like after like 11,000 and a half, whatever, like it would be gone.
No, because it's like in an asymptote. If you half a half a half a half a half a half a half,
Asymptote?
it'll just keep going on forever and never comes to zero.
The idea is that after one half-life period, we have a new starting quantity. And so then half of that part is gone again. It's not the whole quantity disappears in two half-lives. It's half of your starting quantity is gone.
Okay.
So in this one, there's not even a half-life period gone yet, right? This one's about 2 half-life periods, not quite. So you receive half, which is 3.4, but not quite half of that number again. So 2.02 should make a little bit of sense.
If I put in the original quantity, like if I put in 5,715, then you get exactly half of this. But okay.
Okay.
Got it.
Also, guys, please keep in mind, this is a theoretical concept. We're expecting ideal conditions. In the real world, we don't always get exactly ideal conditions. We can get pretty close. So there may be a little bit of error that shows up. So if you had some sample, you put it in a container so that it didn't get contaminated. You jump in the time machine, jump 5,715 years in the future. You went and tested that for carbon-14 data. It may or may not tell you it's exactly that old. It's going to be really close.
If you're in a time machine with it, technically you would have aged that.
No, not you with it. It stays outside. You go.
Oh,
You go
okay.
forward.
I was like, I'm not.
You jump in, it stays out.
Okay.
Did anyone
I understand.
see that? That was really cool.
No, unfortunately that doesn't exist. But that's the idea behind this thing of half-life.
Ignoring the errors.
Ignoring the reality that that can't happen.
Ignoring friction.
I don't think we'll ever invent time travel. Because if we did sometime in the future and I look back in 2013 and say, man, it's so class. I want to go visit this. I don't really invent it. They come back.
Trent, you're rambling. Caught it out there, but it didn't hold that.
Yeah.
Remember the time?
But what if you forget? Saturday.
Well, the other thing steady diets and government cheese.
Dave Ramsey would be very mad that you bought a $35,000 car. I'm
Who
just
would?
saying. Dave Ramsey.
No, I'm not telling you I bought it. I said a car. I didn't say I bought that car.
Well, I should hope not. Dave Ramsey would be very upset with you.
Why?
Dave Ramsey.
That's an expensive
So if you were to take a time machine and go back and show your grandpa. So if I never existed, would you
And that was appreciated about 30% the second you dropped it off.
So
You
then,
drove it off
like,
the
if I was
lot.
never born, I would not have gotten to kill that.
Tell me yo-yo ma.
What wasn't the time machine that went back and said it was a bad idea, so they stopped themselves from inventing it?
You went back in time and
They'd be stuck there.
your time machine disappeared. And so would you.
So if I went back in time, I'd kill my
Depending on what you do.
grandpa. But my grandpa would be dead.
Time travel. What?
If I went back in time, I'd kill my grandpa.
Okay.
If you go back in time and like kill a butterfly.
Now, let's quit jumping in our time machine. Let's go back to class and let's look at this question.
Hey!
Wasn't it? Oh no, that's the chaos thing. What's the butterfly thing?
Hey, focus.
Back to the
Please.
future.
A car costs $35,650 when new. If the value of the car is $22,500 after 2 years, what is the value of the car when it is 5 years old and when it is 10 years old? And then a third question would be, when does the car have a value of $100? So, there's some things we got to do to this problem. Yes, sir.
How many miles were being put on the car each year?
Doesn't matter.
That's
But old cars gain value without use. Usually.
A fixed
No, it
amount of
depends on the car.
no. It actually is a legitimate question to say how many miles are on the car. Is the maintenance record done well?
Is there
We're
a
going.
If it's a used.
Hey, we're going to assume for this particular scenario that the car was well maintained, was driven the average number of miles per year of automobiles within the states, Also, we're going to assume that it was not within any accident because extra damage, that is not an expected amount of damage. We're just assuming that as it ages and as it's used correctly and maintained well, where does its value go? Okay? That's our assumptions.
Do we use the same formula?
So this is a pretty